If you find a point on a function's graph that's at the top of a hill or bottom of a valley, then the derivative of the function at those points will be zero. These points will have a horizontal tangent line. Example, determine the points at which y equals x to the fourth minus 2x squared plus 3 has a horizontal tangent line. First, you take your function and you take its first derivative. The first derivative of this function is 4x cubed minus 4x. Now, in order to find a horizontal tangent line, you set that first derivative equal to 0. Over here on the graph, at a valley's bottom or a hill's top, there is 0 rate of change, so your first derivative is 0 at those locations. 4x cubed minus 4x has a 4x in common, so if we factor out 4x, 4x cubed divided by 4x is equal to x squared. Negative 4x divided by 4x is equal to negative 1. This factor is a difference of two squares, so you take the square root of each term. Square root of 1 is 1. Put in plus minus signs. If you were to FOIL this back out, you would get x squared minus 1. All three factors have a variable, so put all three factors equal to 0 and solve for x. 4x equals 0 when x is 0. X plus 1, that's equal to 0 when x is negative 1. X minus 1 is equal to 0 when x is positive 1. These numbers underlined in purple are critical numbers. They give you the x values that can occur at a valley floor or a hilltop. To get the precise location, you go back to your original function, and one at a time, you plug in your critical numbers. When x is negative 1, and you plug it into your original function, you get 2. So that tells us the pair negative 1, 2 is one of our locations with a horizontal tangent line. The critical number 0 plugged into the function gives us 3, so 0, 3 is another location. And when the critical number of 1 is used in the original function, we get an answer of 2, which gives us the point 1, 2. A number plugged in paired with the answer you get gives you the ordered pair location. In our second example, we have the function x cubed minus 3x squared. Its derivative is 3x squared minus 6x. Setting that equal to 0, factoring out a 3x, both terms are divisible by 3x. That gives us an x left over from the first term and a negative 2 left over from the second term. 3x is equal to 0 when x is 0. X minus 2 is equal to 0 when x is 2. So at 0 and 2, you will either have a hilltop or a valley floor. Going back to the original function, substituting in 0 gives us an answer of 0. So that tells us 0, 0 is one of our points with a horizontal tangent line. Turns out it's a hilltop. The other critical number of 2, when plugged into the original function, gives us negative 4. So the point 2, negative 4 is another location with a 0 slope or horizontal tangent line. For a third example, we have the function x squared plus 2x. The first derivative is 2x plus 2. This is equal to 0. Factor out a 2, and that leaves 2x plus 1. 2x plus 2 factors down to 2 times x plus 1. Since 2 has no variable, we don't worry about it. X plus 1 is a factor that does have a variable, and it is solved when x is negative 1. When x is negative 1, in the original function, Its value is -1, so pairing that up, we get -1, -1, and this function only has one location with a 0 slope or horizontal tangent line. We also had one that was in your homework. It was a problem that I felt the need to go over with you to take the first derivative. We have three terms in the numerator all over a common denominator of x. You can break up each term in the numerator with a common denominator of x. So 8x squared over x minus 5x over x plus 7 over x. 8x squared over x, you cancel an x from top and bottom, it leaves 8x. In the second fraction, the x's cancel one another, leaving -5. And for this third term, we can move x up next to the 7, but we have to negate the power. Taking the first derivative, we have 8, 0, because it's a constant, -7x to the -2. And if you prefer, you can move that x back to the bottom. If you cross the fraction bar, that power has to change sign. The notation for average rate of change is usually given by delta y over delta x. Delta y is the change in function value. Delta x is the interval length. For a function f of x over the interval a to b, you may find average rate of change by taking the function value of the right endpoint minus the function value of the left endpoint divided by right endpoint minus left endpoint. Example, consider the function given. Find its average rate of change over the interval, then find its instantaneous rates of change at the endpoints of the interval. So this function is a line, slope 4, y-intercept at 5. The interval 1 to 3 specifically talks about this green highlighted section. 4 times 1 plus 5. What I'm doing is putting in the first number from the interval into the original function. I get a 9. So if I put in a 1 and I get an answer of 9, that means the 0.19 is the beginning of the part we're investigating. The right endpoint 3 subbed into the original function. 4 times 3 plus 5, that's 17. So 3 gave us an answer of 17. So that's the final point. And in between these 2 points is the function over this interval. To find the average rate of change, you take your second function value 17 minus your first function value of 9. 17 minus 9 is 8 over the length of the interval. Well, from 3 to 1, that's 2 units. So right endpoint minus left endpoint is equal to 2 units. The difference in function values or change in function values divided by the interval length is 4. Since this graph is linear, it has a constant rate of change, which we also know as slope. And that's true for any linear function. Its average rate of change will be the slope. The instantaneous rate of change at the endpoints is calculated by taking your first derivative. Well, refresh our memory, our function was 4x plus 5. First derivative is 4. Well, since that derivative is a constant, that means that our line had a constant rate of change. And again, that's always true. For lines, your rate of change is the slope. The first derivative, whether you sub in a 1 or a 3, your left endpoint or your right endpoint is going to be equal to 4 both times because there's no variable in which to sub. Now let's look at one that does fluctuate and move around, has some curvature. Consider the function given, f of x equals negative x squared minus 6x minus 3. I have the graph over here in black. So it's this little arch. The average rate of change, let's find the function value at the left endpoint, f of negative 3. We sub in, carefully calculate, we get 6. So negative 3, 6 is the first point we're going to investigate. The right endpoint, positive 2, f of positive 2, carefully plugged in, gives us a negative 19, and that's this other point in purple. Our left endpoint is this point. Our right endpoint is this point. So we're only investigating part of this arch. This purple line connects those 2 points. It's called a secant line. Secant is derived from Latin, and that means cut. So we cut through the graph at negative 3, 6 and to negative 19. The slope of this purple line is what we find with average rate of change. Second function value, negative 19, minus first function value of 6, that's negative 25. The interval length, 2 minus negative 3, right endpoint minus left endpoint, that interval is 5 units long. So negative 25 divided by 5 is negative 5. Negative 5 is the slope of this purple line. Instantaneous rates of change at the endpoints are the ones with the orange lines. The first derivative, if we take, sorry, I'm jumping around, y'all. If we look at our original function highlighted in teal, or whatever color you want to call that, our derivative is negative 2x minus 6. First derivative is negative 2x minus 6. Our endpoints are negative 3 and 2. Those are our interval endpoints. If you sub in negative 3, negative 2 times negative 3 minus 6 is 0. F prime of 2, negative 2 times 2, that's negative 4 minus 6 is negative 10. So at the endpoints, we have a horizontal tangent line because the derivative is 0 at negative 3. And then on this endpoint, we have a tangent line slope of negative 10. Because of the varying curvature, our endpoint slopes vary. This purple line shot through both points at the same time, so that's the average rate of change was negative 5. Well, if we go back down here, if you were to average 0 and negative 10, you would get negative 5. I hope this video has helped. Reach out by phone or email, ask in class if you have any questions, and I'll do my best to help out.